So I suppose the first question for Nigel is, you love insects, you study insects, but you hate this particular insect. Why?
Uh, well, fire ants are one of these really insidious species that have, been able to dominate their environment. And the fire ants, they're an ant, and we also have many different ant species in Australia. So we've, I guess, broadly, ants are in the same order as bees, wasps, and sawflies, so hymenopterans. And there's about 12,000 species of ants worldwide. And in Australia, we've identified about 1,300 species, but that's only about 50% of the diversity of ants that probably are found in Australia. So Australia in particular has a huge diversity of ant species. And some of the nests of the native ants can be found in sort of the same spot for decades or even indefinitely. So when we think about some of the ants that are native to Australia, sugar ants, some of these queens can live up to 23 years in captivity, and their nest can stay in the same spot, and the queen can be replaced again and again by the colony if the existing queen dies. And we know that some meat ants' nests, so the Iridomex purpureus that make those big meat ant nest mounds, they can live at least for up to 80 or plus years, because I've talked to grandparents of kids at environmental education centres that saw the same ant nests being active when they were a kid. And
So Nigel, those are the nice ants. What about the
yes,
fire ants? Because the
well,
Invasive Species Council said they're worse than foxes, dogs, camels, and cane toads and veromites combined.
yeah, they're one of the 100 world's worst invasive alien species, and they're particularly nasty because they're so aggressive. So when we think about sort of we think about Australian ants, like if you're going to have a picnic or if you go outside, you get bitten, they're annoying. But fire ants are next level. So instead of one or two individuals attacking you, they can attack in their tens, hundreds, or thousands. And they are such an aggressive group that they actually sting en masse, and they're able to just not only sting en masse, but they can actually completely redefine the ecology of areas. So, for example, they can take over sporting fields, they can take over local sort of native areas, native bushland areas. They're found in urban areas, and their adaptability makes them one of the worst invasive species that's out there, because they're not like other invasive species that are found in Australia. They can be found across all different environments. So they're not just found in agricultural systems or in forests. They go from urban, peri-urban, and into bushland and into agricultural systems. So they've got the ability to cross over these different environments, which makes them such a crucial pest.
Is there anything about South East Queensland that they particularly like, or is it just mere chance they got a foothold here through arriving in the port?
It's yeah, I'm sure they love the climate there. It is one of the things that they were first identified in 2001, but that was when they were first identified, and so they're most likely there before that. And one of the critical issues that happened, well, that didn't happen when they were identified, is that they weren't eradicated immediately. So this is one of probably if you're looking backwards 25 years ago, one of the critical sort of mistakes that was made is that the investment wasn't put in to remove them as quickly as possible. And there's been multiple incursions of fire ants into the port of Brisbane after that, but also all around Australia. And what is happening now, and also into southeast, into northern New South Wales, the programs that are now in place eradicate any new incursions that come through. But for Southeast Queensland in particular, they were allowed to sort of their populations were allowed to grow to such a point that they couldn't be eradicated through the amount of funding that's currently given to manage them or eradicate them. So we're at that point now where the populations are so large that if we still have the opportunity to eradicate them, but there needs to be the next level of investment. There needs to be a much stronger community engagement. There needs to be a whole range of different methods to try and control them than what would have happened 25 years ago.
Okay, so we'll get to eradication, and I'm glad to at least hear it's possible as long as the will is there. But I just think if you mentioned there about how they affect all sorts of ecological systems. I mean, we make a great fuss about how much they might spoil picnics or something like that, but I mean, it's flora, fauna, native dwelling birds, presumably other ant species as well. Everything can fall victim to the ghastly march of the red imported fire ant.
Yeah, pretty much everything that is that actually forages or is found below 1 meter above ground is easy prey to them. So anything that, sort of is a lot of ant species that are ground foragers will be impacted by them. Small mammals, reptiles that can't compete with them. In agricultural areas, they can actually kill off sort of seedlings and saplings, and they also will farm other pest species. So sap-sucking mealybugs and aphids, for example, they will actually, a lot of ant species do this, they'll farm a lot of pests, other insect pest species to get the honeydew from them. So they become what we call ecosystem engineers. They can change the environment to suit them. They can remove competitors. They can keep species that give them food, and they can modify the areas so that it works best for them as a dominant species.
So what can we do to control them? Because I mean, and I think if you can explain, and maybe I don't know if you've got any slides to explain, the difference between suppression, containment, eradication.
Yep. So I'll just show you. Let's see if I can share this slide.
And just while Andrew does that, you can ask questions through the chat, so please send them in, and I'll challenge Nigel with questions as he goes on.
Can you see this slide now,
Yeah.
Chris?
Yeah.
So basically this is the global distribution of the red imported fire ant. And so you can just see here when it's in the bright red, this is where they're native, and they're found in South East Queensland, but also they're found in China, Taiwan, but also in North America. And one of the most likely way that they did initially get into Brisbane was probably from America on a pallet. So they're known as a hitchhiking species, and many ant species which are invasive generally move most frequently on human goods, particularly in pallets. And particularly in South East Queensland, this is sort of from the National Fire Ant Eradication Program response. So this was actually put together a few years ago. So this is the ideal method of containing the fire ants. So you have a sort of in the red, they've got a treatment boundary, and then they've got a surveillance boundary, which they're not meant to get out of. And so this is meant to be and what this horseshoe is meant to do, as they treat the boundary, the horseshoe containment zone was meant to get smaller and smaller. But what has happened inadvertently because of funding issues is that it's changed quite dramatically. So the sort of you can see the treatment boundary has pretty much disappeared, and there's now a surveillance boundary, and there's lots of controlling going on within this, but there just isn't the funding to actually eradicate them, except they've started a sort of a rim down just on the closer to the border to the south. So this is actually part of the reduced treatment plan that's come because of funding issues. And if we just look at this is the current area of spread. So this map is in 3 parts. I couldn't get the whole thing onto one slide, unfortunately. But if we just look at sort of this area here, you obviously know this area better than I, but basically this is meant to be the containment zone up in this part of the world. And you can already see that the most recently fire ants have been found up near Caloundra. So this number here is basically the number of sightings of nests that have been found over the last 12 months. So they're already moving further north than the containment boundaries identified. And as we move further into South East Queensland, you can see here there's 2 biosecurity zones that they've been developed here. And you can see in the main biosecurity zone, this is where they're most prevalent. And in biosecurity zone 2 and biosecurity zone 1 is where they're moving further out towards Gatton. There's a few nests found out there. But essentially, yeah, in southeast, towards Logan and Brisbane, this is where the dominant number of fire ant nests are found. And also moving further south. You can see, yeah, again, there's further few south here, and again, the few incursions that went down into southeast northern New South Wales.
Now, you called them a hitchhiking invasive species, and there's a lot of roads, there's a lot of earth movement, there's a lot of building going through surveillance and containment zones. Is that how, in a way, they're not, how on earth can you possibly contain them? Short of having, like the pest, the fruit fly control stops we had on the roads years ago.
Exactly. That's the critical thing. Most of the movement of fire ants outside and internally of those containment areas is through human movement, through sort of livestock movement, through sort of grass or mulch, or so a lot of the time, for example, coming into northern New South Wales, they came into northern New South Wales in grass turf. Again, they'd been sort of checked and they'd been actually registered to be cleared, but there were fire ants found in them. So they're the ones that are found, and so there is they move a lot of the time by humans, but they do have their natural ways of moving. So the winged females, and also the males, when they're produced, they'll fly. They can fly, about 3 kilometers, so not far, but they can definitely cross over water bodies and colonize new areas. And I guess one of the more sort of exotic ways for them to move is by rafting. That is, that they can actually, when a nest is quite large and it gets flooded, instead of what happens with a lot of ant species, particularly Australian ant species, they might just get flooded out. But the fire ants can actually sit on top of the water and basically, as a group, sort of raft down the riverways in flooded waters. And that's a really, particularly in their native areas in Brazil, in the rainforest, in the natural areas where it does get a lot of rain, that's one of their evolved ways of actually moving around their environment.
I've just been at Australia's Oscars on the Gold Coast, and this sounds like a pitch for a horror film. I'm sure someone might make a horror film like this because it's terrifying. You've got a graphic of the sting potential of these things. Could you scare people even more by putting that up?
Sure. Let's go back. Here we go. So this is the Schmidt sting pain index, and this is one of the really, again, it's one of the fun things some entomologists do when they just, they like to be, if they work with particular groups of insects, they like to get stung to determine how painful the sting is. And this goes from 1 to 4, and you can see here, like on the Schmidt pain index, fire ants, an individual. This is one of the things about the index of individual fire ant is light and ephemeral and almost fruity, and it's like a tiny spot singed a single hair on your arm. but then a fire ant never stings individually. They always sting in hundreds or thousands. So this is where the problems arise. You know, an individual doesn't do much damage, but they never sort of work as an individual. So then you go up to these, particularly at level 4, these bullet ants and hawk wasps, they're very much running a hairdryer that's just been dropped in your bubble bath. That's sort of getting to extreme pain, and sort of, yeah, will have you clutching, you know, in the fetal position for a few weeks after getting stung by these guys, as an individual. But you know, fire ants have killed people through anaphylactic shock in the US. They've certainly, again, as a group, they've killed, you know, they'll kill livestock, they'll kill you know, mammals. They'll quite happily, if an animal is, you know, set in one spot, they will actually, you know, quite easily kill it because of the number of stings that they can actually inflict on individuals. But so yeah, you have this pain index for all insects. But yeah, that doesn't it puts it into context for an individual, you know, ant. But yeah, you multiply that by hundreds or thousands, which I'm sure many people here have probably been stung by fire ants. And also when you compare it to other ant species as well, you find some of the native ant species like bull ants, they're probably up between a 2 and a 3. And if you've ever been sort of stung by a bull ant, they're particularly nasty in Australia.
Well, that's true. Look, geographers, we love maps. Can you just go back to that world map? Because we've had a question from someone asking, are there any environments in the world where the fire ant lives in a metastable ecosystem? That is, that the fire ant doesn't dominate the ecosystem that it's living in.
This is one of the really interesting things about what we don't know about red-imported fire ants. So what my colleagues in North America have found is that what happens in the North American ant fauna isn't as diverse as Australia. I sort of was talking about that at the start. And usually in the first 5 years of them being colonized in an area, it's when they cause their most problems. But after that, the environment does go into a stable state, effectively. Now, so we know that in the US because they've been there since about the 1930s. Most of the areas where they've colonized or they've invaded recently, so Australia was in 2001, but also in China and Taiwan, I think they were about 10 years ago. So effectively we're in an environmental state which has been turned upside down, and the ecosystems particularly in South East Queensland, the ant fauna here is very different to North America. So, and one of the things that I'm really interested in studying here is actually how how our native ants are responding to red-imported fire ants, and initially through their first sort of initial interactions with them, but then through competition. Australia has a very competitive ant fauna in the sense that the ant faunas in the 1990s were put into what's called functional groups. So there's a dominance group, there's a subdominant group, there's subordinate groups. There are climate specialists, so there's special species of ants that are just found in the arid zones. They're heat-loving specialists. But in South East Queensland and also in northern New South Wales, you get these different groups working together, and it's sort of in it's not necessarily a stable state, but they sort of work together. And one of the things that we want to actually look at is when the red-imported fire ants are in the state for 25 years, is the ant fauna still in this area the same as what we'd expect it to be before red-imported fire ants were introduced? And if it's different, what are the species that are actually able to compete with the red-imported fire ants, or what species are actually able to coexist with them? And that will then give us some ability to predict what might be happening, because they will actually, that, as you saw from the maps before, they are moving. You know, there is movement of these the red imported fire ants, and how quickly they move. If they're moving from their the current distribution further up naturally, but compared to if they actually are moved by humans into a completely novel area, how will they potentially respond, or how will the ant communities potentially respond to that?
Okay, well, let's move into the control area, what we can actually do. And please send in some more questions because that's interesting. Now, I've heard the fire ant control people say, well, look, if Nigel's very critical of us, but if we hadn't done anything, their fire ants would now spread from Longreach to Bowen and down to Canberra. So a lot more of Australia would be covered. They say they spread here at about 4 kilometers a year. In China, it's 80 kilometers a year, and in the US, 40 kilometers a year. So the efforts are managing to constrain them, if not actually stop them. But what are the agents of control and how do they work?
Well, in Australia, we are fundamentally using chemical controls. So we are controlling them by using a few things. So firstly, sort of a granular treatment. So if for example, if the chemicals are rapidly dispersed, it's an insecticide in a granular form, or it's an insect growth regulator. But there's also direct nest injection. So I guess the insect growth regulator is very much similar to what you find in fly sprays or flea and tick treatments. So they're known to have a low toxicity to humans. They're non-toxic to mammals and birds, and they're rarely toxic to adult insects. What the growth regulators do is that they prevent the insects from going through their life cycle or molting. So insects go through this stage of being an egg, a larvae, a pupae, and an adult. And so that stage of when they're going from an insect into the pupal form, an adult, that's to me, that's probably the most amazing part of evolution that we know of. Because what is happening at that point in pupation is that they're going from, you can think about a caterpillar going into a butterfly. What is happening there is that the external body is changing, but all the internal organs are also completely changing. So effectively, an individual is going through a complete reorganization of the external parts of their body and also their internal body parts as well. And these insect growth regulators, which I think pyriproxyfen and S-meoprene are the chemicals, what they do is that they inhibit that life cycle from continuing. And they're mimicking a natural hormone that prevents the larvae from maturing. And what they do is, because they're in a granular form, they're spread out in the environment, and then a lot of the insects, where the fire ants are found, they're sort of baited. The worker ants, they're all the workers, all the ants you ever see are females. You very rarely see a male unless you see flying males. And what you normally do is that those worker ants will take the granular form back into the nest and basically feed it around the nest. The queen will feed on it, the larvae will feed on it. And so what is happening is, once the larvae feed on it, they won't be able to go through their life cycle. And so that will slowly reduce down the population size of the fire ants. Now, with the insecticide granular treatment, it's another chemical called indoxacarb. And it's what you find in cockroach baits or flea collars. It again works in a similar way. It's just basically a chemical that is fed to the nest, and it basically has this ability to kill off pretty much any insect. So they're not chemicals which are specific to fire ants, but they're what we use for cockroach baits and flea collars. They have a low persistence in soil and water, and they also break down quickly with sunlight and microbes. So if they're sitting on the surface, the soil surface, they usually, and they're not taken back to the nest relatively quickly, they'll break down. And that's why they're used in broadcast baiting, because they're used and they're meant to sit on the surface, but relatively quickly be taken down to the nest, or they just break down into the environment. And so one of the things is when they actually have they've got a minimal toxicity to mammals and also humans, but they're primarily based on, they will impact on insects and other invertebrates as well. There's also oh, sorry, Chris.
No, are there any silver bullets being developed in high-tech labs anywhere?
Well, a lot of the time there's the ones that, so we primarily using the chemicals. We're also using direct nest injection, which is fipronil, which is a much more toxic chemical, but it's put directly into the nest. The other methods that are currently being used is is called a hot water nest injection. So for those, when we can't use chemicals, or when chemicals might be inappropriate, it's used in the US, and it's just been introduced into Australia just to do some testing. But essentially it's like you can think of a hot water system on the back of a ute, and basically there's a big long wand attached to it, and you basically inject boiling or near close to boiling water, so 97-degree water coming out of the wand and spraying the ant's nest. And that's a non-toxic way of actually directly killing the ant's nest. The other way, there's two other ways that have been known to as biological controls for fire ants. One that is actually quite common, there's a forward fly, which is a species of dipteran, of true flies, and they parasitize ant bodies. And so when you're talking about movies and horror movies before, forward flies should be in that, because what they do is that they parasitize the ant body. The female lays an egg on the ant, then the larvae then get into the inside the body of the ant, and they decapitate the ants when they pupate. So they basically come off with, it takes the head off the fire ants. They're really poorly known in Australia. They do impact native bee colonies, and so again, we don't want to go down the route of importing another natural enemy, another forward fly from South America into Australia, because that's exactly what that's a cane toad example right there. But we do have native forward flies in Australia, and so there's some actual testing we could do on those. And there's also fungus that we can use as well, which is basically used similar to what we do in integrated pest management in cropping areas, which is basically a fungal pathogen that can actually grow on the ants.
Okay, one of the questions come in about South America. Are they dominant in their environment? What damage have they done, or is the environment stable? So what about places where they've been for yonks?
Well, where they're native, they're relatively stable. They're a dominant species in their natural environment, and so that's where the environment in which they are natively found in South America. They dominate the ecosystem, but they also have a lot of other natural enemies like aardvarks or anteaters. They actually have mammal species that will actually eat them as well, and eat them in huge numbers. So there are other predators on the ants that have evolved to not be impacted by being stung multiple times. But yeah, there's essentially that element of where they've evolved. All the other species that have evolved with them, or that we currently see in those environments are there. But again, they impact on agricultural systems in South America, where they're quite active in. So there is an element of them being sort of, I wouldn't say a stable state, but there are natural enemies that have evolved to feed on them.
You wouldn't advocate bringing in aardvarks to Australia?
I think there's sort of, again, there would be questions asked.
Okay. Another question is, what are the main pathways for the fire ant being able to act so cohesively as a group? Is there any assessment of their sentience? I mean, we know all ants are incredibly smart. Their social
Mm.
systems are very developed. Is the fire ant any different from them, or is it smarter?
I wouldn't say they're any smarter. I think they're just more aggressive. There's an element of aggressiveness that, I mentioned before about this idea of functional groups, they they're in a genus called Solenopsis, and there's a few invasive ants that are within this group that just they're able to travel, and they're much more adaptable. So when you think about invasive species being insidious, why they're so bad is because they are so adaptable. It comes from their ability to adapt to new environments, being able to rapidly increase their population numbers, and able to find resources really quickly in order for them to get to high enough numbers, and then for the females to be able to reproduce. So they're probably, they wouldn't be smarter. It's just that their biology enables them to rapidly take advantage of areas where basically naive areas that haven't been exposed to these ants before. They can come in and dominate very quickly. And there's quite a few, there's another example, there's crazy ants further up north in Cairns and Darwin. They've done exactly the same thing. They're able to adapt to when they're introduced into the environments, that they love human movement. Basically, they work well with humans. They take advantage of our trade, and are effectively working with humans to increase their distribution.
So you seem to have a grudging respect for them.
Absolutely. You find that the ants, in terms of the evolution of insects, the Hymenoptera are one of the most evolved groups, and their social structures, their ability for when an ant, first comes to make a nest, she'll be she'll actually produce enough offspring to mainly look after her nest and build the nest up. And it'll get to a point, she'll actually make sure that her nest is sort of working effectively before then she'll produce new workers to actually go outside the nest. So the queen has the ability to modify the structure of the casts or the different groupings in her nest according to its size and according to the needs of the group. And that's a really amazing aspect of what ants can do. The female ants are diploid, the males are haploid. So that so that's why you only see the female, like the nest you see is all females. The males only survive for a couple of weeks or a couple of days, purely to mate and to reproduce. That's all they use males for. So I guess you always have a grudging respect to a very successful group that just is primarily made up of females. And that's one of the reasons why they're so effective. They can use chemical controls. They communicate, with chemicals, like the pheromones. So they can actually, that's how they interact. And that's one of the reasons why fire ants are so aggressive, is if one fire ant finds what it thinks is a intruder, it releases a pheromone, and the entire nest comes out to actually sort of help it. So it's from a biological point of view, they're really quite an amazing species.
Okay, well, let's flick the switch to humans and what we do. And a good question, and do keep the questions coming in. How is fire ant risk assessed in Queensland in terms of identifying areas prioritised for eradication treatment? E.g., is it based on their impact on human populations, agriculture, natural ecosystems, species, or dare one even say politics to prevent the spread across state boundaries?
I suspect it's a lot of it is based on all of those things, and also funding. Probably comes down to a lot to the funding. I think a lot of the eradication is being based around the edges. So they don't want it to actually escape from that horseshoe. I think that's sort of probably the, what is happening like around, in the areas within the horseshoe where they're already at high numbers. That's going to be, if there is an eradication program, that enclosed area will probably be the last area that's actually sort of worked on. They're trying to work on the sort of exterior points, and the ideal with the horseshoe is to reduce the horseshoe size down and down and down further. So that's the priority, is to make sure that they don't want it to expand, they want it to contract, and contract sort of closer and closer back into the epicenter. But again, the issue comes from that's where the politics comes into it, and the social license comes into it, because people who don't like having, or think that the chemicals are bad, or that they cause problems to their livestock or to their own human health, or they get into waterways and kill off fish. And when there becomes this misinformation campaign, that causes fear. And also the fear comes from, if areas go into quarantine, how will and how will businesses be compensated? Who's paying for that? If a business has to shut down for 3 weeks to try and control fire ants, how will they be compensated? And why do they have? The question always comes: why do they have to pay for it when the next door neighbour doesn't?
Well, this is a really interesting area we'll move into now. There was a story in the Courier Mail this week suggesting that some of the people who'd pushed the fluoride debate in local councils and fear-mongering around fluoride had now shifted to fire ant control, and saying that, scaring people, that the fire ant treatments would poison their backyard. We've got a question here. I've seen comments from private landholders and some politicians claiming that aerial broadcasting of red fire ant baits is adversely impacting non-target native species and ecosystems generally. Is there any truth in this, or is it misinformation?
Well, it comes down to, what are they talking about specifically? The broadcast baiting, as I sort of mentioned before, a lot of those the baits are insect specific. So I guess if there is an impact on the environment, it is most likely to be other invertebrates and other ants. But examples where there's been conversations about cattle being killed off, is very it is very unlikely to occur, because a lot of these chemicals are actually being put into water troughs of cattle in the US for decades. So a lot of these chemicals have been in our systems for decades as well. As I mentioned, most of us have probably been well and truly exposed to these chemicals if we put cockroach baits, or if we have pets. And there is there's always examples when you put a chemical out, there is going to be an impact of it. It's not, I'm not, any chemical that, any bait or any chemical that you put into environment will have an impact on the native environment. And particularly with the other insects that might be found in those areas. But one of the problems in general is that the surveillance of, we don't have any surveillance of what's happening in a lot of the time into the native fauna, particularly the invertebrates. That's probably where the biggest impacts are, but that's also where the biggest impacts are occurring with the fire ants as well. So you're in a situation where you're trying to minimize the overall impact. And this is firefighting. This is, we're at that level where we're firefighting to try and contain the spread of a serious pest species.
How would, you mentioned before that you've been disappointed in terms there wasn't total eradication in that first outbreak. Mm-hmm. What can we realistically do now? And we spoke earlier, and you spoke about elevating the political status of this issue. I was talking to someone, a bushwalker, who was saying he'd tried to get his local councillor involved, who just said, "Oh, it's a state, it's a state issue," and passed the buck. What have we got to do to actually get some real action here?
Well, one of the critical things I think is to, at the federal level, is to remove it from the agricultural portfolio and actually put it into the Prime Minister's portfolio, or at the state level, put into the Premier's portfolio. This, at the moment, it's not considered a whole of society problem. It's at the moment, it's still considered an agricultural problem. It's in the agricultural portfolios. So if this was, this is invasive species, has an impact on our way of life. It will impact on going out and having barbecues outside. It'll have an impact on sporting. It's having an impact on sporting fields. It's having an impact on hospitalizations, and it also has an impact on the economy because there's costs there. So I think that's one way to elevate it. And it's also, I mentioned before about the social license. I think there has to be the idea of not just an education campaign, but a campaign to say, to bring it into not just being a South East Queensland problem, but to being a whole of Australia problem. We don't want these species, the rest of Australia doesn't want the species to get out of the containment zone. But the only way that will happen is that if you band together and say this is actually a whole of country problem, not just a problem in South East Queensland. So, and that's and by doing that, you also need to increase the funding of how to control them. So, at the moment, with the funding that's going into it, it's actually, it's contained the actual, it's contained fire ants, and they're just increasing by about 4 kilometres a year. So we're the only, pretty much South East Queensland has been the only place to successfully contain fire ants. No matter how much there's a lot of, there's never a good way to deal with the fire ants, in terms of trying to remove them. And mistakes have obviously been made, but what is happening now is that they're actually being contained, and that hasn't happened before. So that's one of the few shining lights we have. And if you look at that, that's based on the current funding that's given to them, which is meant to be the eradication sort of level funding. So and this is where the political will comes in to say, if our government's willing to pay the same amount of money, basically for the rest of, it's about $150 million a year is spent to try and, do what we're doing now. And that's actually meant to be part of the containment package. Basically, to eradicate them, we really need to actually double that. But, where are we going to get that money from? What won't actually be funded to pay for that? Is it, do we reduce our funding on military spending, on AUKUS funding to actually control fire ants?
Don't suggest doing away with the 50-cent public transport in Queensland.
So yeah, there's I think there's this is where getting some sort of social license is really critical to go to look at it from a whole of, not just a whole of government approach, but a societal issue, and also to see how we can solve it as a problem, because as it is controlled and contained to a level which is in itself an amazing feat.
Well, there's actually a call to action for our participants. Someone suggested sign the Invasive Species Council petition to get more funding from the government to control the fire ants. So that's something that can do. I mean, something in this political, I was very interested to see the Australia Institute, who are a left-leaning think tank. They did a report about fire ants just a few months ago. And they said that the 6 Queenslanders could die each year if there isn't better eradication and containment. And the annual bill for households will be about 200 million if they're not eradicated. So they've done a lot of they've looked at the real costs and says it needs to be stepped up. I mean, there's been Senate inquiries. There's no dearth of information on this for the Polly's Act, is there?
No, I mean, basically, I was part of the Senate committee hearings that were run probably, yeah, sort of about 10 months ago. And so there's plenty of information that's available. Probably, I mean, we know, you know, effectively, one of the things we don't know is actually how the species is working in Australia. A lot of our information, there's a lot of money that goes into the controlling, but we don't actually have a lot of, and again, we're reliant purely on the chemistry and also the growth regulators. And that's probably the biggest challenge that we have at the moment, is because in order to control, not just eradicate species, but to control them, we know from pests in agriculture that integrated pest management is the main way to try and manage problem species. And so if you just rely on chemistry, we've known this since the end of World War II or even before that, is that species will develop resistance to chemicals. And fire ants in the US have already, they've developed a resistance to fipronil for that direct nest injection. And you need to have a suite of different methods to try and control them. For example, if they're, for many of much of the population who doesn't want to have chemicals on their properties, can we use the sort of the direct heat, direct hot water method to control them? Can we use, some of the native forage flies and actually use natural enemies to go out there and control them where we can't see them at all? We need to actually have more sort of firepower in our toolkits to not just control them, but to eradicate them, because really the reliance just on a few chemicals is, it's fantastic we can do that, but we know just from fundamental biology and for the more chemicals you put out to control a species, the quicker you get into the resistance for that species. And then you then have to put even heavier and heavier chemicals out if you want to control them, or that you just let them rip. And that's the, we know we've got, that's a prediction that comes from just basing our fundamental control methods on chemistry.
Wow, now we're just in the dying few minutes. I don't know if there's any other questions from the viewers, the participants. Please send one through. I mean, everyone's talking about the Olympics. Do we risk having the fire ant as the mascot for the Olympics unless we're serious and get on with it?
I mean, it's a great sort of, this is, where again, bringing the sort of community in, if to eradicate the fire ants before the Olympics is a great way to go about trying to eradicate them. It's going to be a lot of the natural environments where people will be going. You don't want to have them completely sort of decimated by fire ants, particularly around Brisbane. Fire ants there's a lot of nests around there, and one of the things that again, this idea of the containment zone. The area around Brisbane is going to be one of the sort of last areas that'll actually be sort of under the eradication sort of zone, because that is where it's really getting close to the epicenter of where the fire ants are, and actually sort of bringing them in closer to the to basically to the edge of the water and throw them off is really important. But yeah, it's that was talked about 2 or 3 years ago, and again, the longer, for every few months that it takes to actually not do anything more, it's less and less like, it's obviously less and less likely to even have a chance of eradicating them by the Olympics. And yeah, they could become the unfavored mascot of the games.
Well, let's hope not. Just to conclude, E.O. Wilson, the great ecologist, said ants have the most complicated social organization on Earth next to humans. So I suppose, is that their Achilles heel, or is that their armor? This incredible
It's
social system they have.
it's where I mean, it's one of their success strategies. You know, there are some like not with the fire ants, but there's other species which are, you know, that can actually live in nests which are, you know, tens of kilometers in size. And as I mentioned, one of the things about ants is that in terms of their diversity, there's it's not about there's so many different species out there, but it's always these few, like the fire ants, that have a particular sort of ability to associate with humans. So, I mean, the thing about, you know, fire ants, why they're successful is that they have a very close association with humans, and they can adapt to our environments. So that's what makes them, basically, as long as humans are successful, you know, invasive species like fire ants are also going to be successful. So you know, that's is where we have to develop skills to actually trying to manage them. But they do have you know, every time you see an ant, you know, when you think of you know, we'll get a philosophical question, might be a bit late to think about it, but it's actually, what is an individual ant? You know, is it the individual worker going around its business, or is it the entire nest? Because it's based around the queen, and basically all those workers are doing the queen's bidding. So this is one of the really fascinating things about ants, is that they act like a single organism. Now, there's many individuals, but they act like a single organism, and you can actually get multiple queens working together as a superorganism. So their social, like their social lives become very complex from a very simple individual.
Well, look, we'll leave it there. Nigel, I'm sure everyone here thanks you. We've had somebody asking if the recording will be uploaded to YouTube or some channel, but the Society and John will inform you upon that. I'm sure many people will do it, and words of thanks and appreciation coming through. Let's hope. I want to get you on again before the Olympic Games so you can explain how we got onto eradication in the 2025 election. Albo committed a whole new lot of funding, which really tipped the balance in favour of the humans from the fire ants. So we'll keep pushing on that. But look, thank you for everyone for tuning in. And thank you for Nigel. Absolutely fascinating stuff. So much more we could have asked. I was intrigued why they're not in Africa. You didn't have them marked on that map of the world. You'd have thought they loved Africa, but we'll leave that for another time. But to one and all, good night. And remember, ants don't sleep.
That's right. Yes. No, thanks for having me. Yeah, no, don't blink.
Okay. Good night.
Thanks very much.